I am Eric Brewer, as introduced, and honored to be here today. I'm going to talk about what's next. And I don't mean what's next for me or for Google or even for the cloud, but what's next for developing software. Because we're in a state of rapid change. I think you know this, you live it. There's essentially a scale problem, an acceleration problem. But at the same time, it means you have tremendous reach and tremendous impact. In fact, I'm always struck by how many small teams can affect 100 million people and approaching 1 billion people. Right? That's impact. And at the same time, especially for startups, you have to focus. You can't really worry about the future. You need to worry about today. And when I think about this, I think about leverage. Right? You need to focus on your core competencies and try to get as much leverage as possible from as many places as possible. And really, the cloud is the key to that. And one of the things we do very well at Google is get you from your prototype into a production service, into a planet scale service. Right? Ideally, you shouldn't have to rewrite your code. You should just spend the time as you like on the core things and get leverage as you scale. Now, when I talk about leverage, I'm going to focus today on development, but it's worth pointing out that leverage includes two other important facets. It's critical that you can engage your users and that you can actually earn some revenue. On the engagement front, Google has a lot to offer that's quite interesting. The obvious one is distribution. Google Play has 1.4 billion users. Right? That's a lot of users, easy to reach. 50 billion downloads last year. Analytics tells you what those users are doing. You can also actually add the inside parts of your app directly to search results using something called app indexing. Take a link right in the middle of the app to drive users to the parts that are relevant. On the earn side, of course, there's ads, both for web and for apps. There's also in-app purchases, and we find that those are driving a huge amount of revenue. And these are just systems that you get as part of the platform that give you great leverage. On the development side, it's also worth pointing out that in Europe, we have over 650,000 Android developers, right? Just in Europe. That's a lot of activity, a tremendous value to Europe as a whole. On the development side, we really have kind of a shift from classic infrastructure being moved into the cloud, which is really just taking your machines and putting them somewhere else, to kind of a second wave that was about virtualizing those clusters and really allowing you to get a variable size cluster of any size to better multiplex your hardware. But basically, you're still managing machines. They just don't happen to be physical machines. The wave we want to get to, this third wave, is really about managing at the application level. And that's what I want to talk about today. And the two things that make this special are that you don't need an operations team, because we can do a lot of the operations for you. And you don't need to worry about the scale of your data. This is exactly how Google operates internally. We have developers that don't have to worry about operations. And in fact, we have tremendous storage systems that scale to arbitrary size, right? And so those are two things we want everyone to leverage, and I'll talk about how we get there. So what's a Wave 3 cloud look like? What's it different? What makes it special? Well, the first thing, which I already mentioned, is the focus thing. Developers need to focus on the code. Right? That means they're not managing machines, they're not thinking about load balancers, or network configuration, or even VM init scripts, or patching the OS. These are all things that are distraction from building a great application. A good example of this is Snapchat. Snapchat has 700 million users. They started as a small team. They've been on Google the entire time. Right, from 0 to 700 million users. In addition to that, they don't have an ops staff. So in some sense, they're the prototypical Wave 3 cloud application. Giant scale, no ops. Exactly what we think everyone should do. right? Google is their ops staff, right? Now, they built that on App Engine, which we'll talk about in a little bit, but that really is the direction we need to go. Another aspect of the wave 3 is big data, although I crossed out the big because I don't think it catches the point. The real point of big data is not that it's big, it's that it might be big in the future, especially if you're a startup. So what I care about is not how big your data is, but that you don't know how big it is. It might be small today and big tomorrow and giant the day after that. Right? So what matters is that whatever size your data, however it grows, which you cannot predict, the platform doesn't change and the code doesn't change. Right? You just use a few more cores and a few more disks. And of course, big data is also going to be how we actually get insight from our users. So we'll talk about that more in a minute. And the third thing that I think is fundamental is future-proofing. So the scalability is part of that, and that's kind of the most obvious part of future-proofing. But it's not the only part. And in fact, when I think about it, I think about a pretty broad spectrum. So for example, one thing we do that's unique is transparently live migrate virtual machines. What does that mean? Well, that means that if we need to do a security upgrade on a machine that you're using, we will move your application while it's running, including network connections, to another machine that's already been updated. So the net effect of that is we can completely refresh our infrastructure all the time without asking you to reboot or take your application down or kill your service. Right? That's the kind of future-proofing. It allows us to have security patches. Another kind of future-proofing is being carbon neutral. All the Google infrastructure is carbon neutral. If you use our cloud, you're carbon neutral too, right? At least for the part that we host. And we're going to promise to keep going that way, so you don't have to worry about that. Another aspect is security. We worry about being attacked by nations, right? You probably don't. I hope you don't, right? To the extent that we're taking these challenges on, you don't have to, right? So that's an important part of it. Another part is networking. We invest a huge amount. We're in our 5th generation of networking equipment now, and it's incredibly fast, and it's going to allow us to do all kinds of things. The obvious one is video distribution. If you want to use video in your applications, you can use the same network that YouTube uses, right? It's a global network with tremendous capacity. And one last one that's different kind of future-proofing is actually pricing. Because we think like a startup, believe it or not, even still, the pricing is really very oriented towards pay-as-you-go, meaning we bill per minute, not per hour. If you use a lot, you get a discount, and you don't have to reserve it in advance, right? So as you use more, your prices per hour go down, right? So if you have a big day and things go well, we can handle that both in the scale but also in the pricing. Now, digging a bit more on the big data side. So the whole point is to leverage your data, right? And obviously you have to collect it and process it. But we really have 3 tools here that have evolved from our previous work. So BigQuery is really basically SQL for your data. So you issue SQL queries. We can run it over your logs or your data however you like, but these queries are just the queries. You don't worry about how many machines it uses or where is the data stored. If you need 10,000 cores and 10,000 disks to do queries on your data, that just happens magically. So in this space, the big data, I think we really are actually pretty far ahead in being on the 3rd wave. It's short amount of code, giant amount of data. You don't have to change it when the data changes. The middle bucket, data processing, this is cloud data flow. It's our evolution from MapReduce. Google, as you may know, kind of started the big data movement through MapReduce, leading to Hadoop and many other pieces. The focus here is, again, write small programs that transform your data from the raw form into the form you need, right? The actual analysis form. And this is a super powerful tool. Again, if you need more cores, more storage, the code doesn't change. It just scales. Finally, we just released TensorFlow, which you may not have heard of, but it's a remarkable thing. This is our open source machine learning framework. It can be used in the cloud or on a device on your phone. It's what we use already for speech recognition, translation, image recognition. So all the things you think about for machine learning, you can now have in your own apps by using this TensorFlow platform. And again, we'll have a hosted version, and it'll be an open source version you can use directly. So all three of these, I think, are Wave 3 applications, or Wave 3 systems, in that you have small amounts of code, a lot of leverage, and the code doesn't change as you go from prototype to production to planet scale. And partially this is because it's the same things we use internally. We already know it works at planet scale because we use it every day. On the compute side, we started with App Engine quite a long time ago. And App Engine is kind of a Wave 3 thing in the sense that it has tremendous automation. I mentioned Snapchat earlier running without any ops staff. That is all on App Engine. And that's been a fantastic platform. The reason it's not completely Wave 3 is it only works for certain kinds of applications and websites and only in certain languages. On the other side, we have Compute Engine, which is the kind of Wave 2 virtualized machine infrastructure. And it's very flexible, can run any language you want, but you have to do more of the work. So it doesn't have the automation that I'd like to see. In the middle is Container Engine, and I put it in the middle because it really is in the middle. It has a very nice mix of the flexibility of VMs. You can run any tools, any language you like, mix them together however you like. So very flexible, but at the same time, we know a lot more about the intention of what you're trying to do. And we can automate a lot more. We can automate the load balancing better. We can automate rolling upgrades. We can clean up monitoring and logging. We can automate various kinds of refreshes of various things, including automatically patching the operating system, which things we can't do in general for virtual machines. So Container Engine is going to have this use of containers, which I'll talk about in a minute, to allow you to build applications in a way that's flexible, but at the same time also enables us to do the automation that makes it ops-free. Right, so I really think it's in the sweet spot, and I really think this is the future of cloud, and that's why we're betting on it so strongly. Another reason we're betting on it strong is because, again, it's actually what we use internally. We launch over 2 billion containers per week, and the way to think about this is every single application that's on Google runs inside containers. And what's somewhat humorous about that is even the Wave 2 VMs, they're VMs, but they actually run themselves inside containers, because containers are how we manage all of our applications, including our cloud, but also search and ads and Gmail and all the things you know about from Google. That's why the number's so big. It really runs everything. Now, there's two reasons we use containers, and we've been using them for about 10 years. The first reason is actually efficiency. We can pack many, many applications onto the same machine, much more so than with VMs. Right, so that's a savings of two types. It's a savings for us, but for cloud customers, it means a savings for them as well. The second reason is that containers are about application management, not about machine management. So our programmers, when they're writing an application, they think about the containers they're using and the scheduling of those using something called Borg, but they don't think at all about machines. In fact, they don't typically know what machines their applications are running on, because it doesn't matter. In fact, we will move them around. So this is really why we believe in containers, because we already know it works. And I kind of feel like we've seen the future internally. We built Borg, the scheduler, to work on that. It worked great. Kubernetes, which we open sourced last year, is the kind of the open source version of the scheduler and manager, or the thing we call orchestration, for managing these containers. But it's based on what we do internally, and actually it's better because we cleaned up and learned from some of our mistakes. So Google Container Engine is, in fact, the fastest way to use containers well. And what I mean by that is a lot of people think about containers just as a packaging mechanism so that you can run something on your laptop and have the same thing run in the cloud. And that is a useful thing that containers give you. But actually, they're much more interesting to me as a framework for automation, right? And so GCE is really, I'm sorry, GKE, Google Container Engine with a K, is about Kubernetes and the orchestration layer, but hosted, right? We do the orchestration for you. So for developers, you do get, in fact, the kind of easy dev test environments and packaging that containers give you. But you get a few other things that are more important, I think. One is you can structure your complex applications as sets of microservices. And in fact, it works quite well to have multiple containers on the same machine implementing complementary microservices. So for example, you might have a web server service and a content distribution service, and they run on the same machine because they're related. They might be built by two different teams and use two different languages. Kubernetes and microservices are great for that kind of thing, where you want to mix languages or mix teams into a more complicated application. Then when you're ready to upgrade, you can actually upgrade that cluster with one command. Because again, we understand what the application is trying to do, how the pieces relate, and how to upgrade either the pieces or the whole thing. So that's what the developer sees. On the ops side, what you see is essentially great management. The load balancing works magically well. It actually knows how much traffic you want and can adjust the number of nodes for that. If you make a new Docker image, you can just copy it to the repository, and we'll start using that version instead. And a subtle one is it's actually highly portable. Because Kubernetes is open source, it means you can run Kubernetes on GKE with us, but you can also run it on-prem, and down the road, you'll be able to run it hybrid. It's a little awkward to run it hybrid now, but it's a very quickly evolving space. In fact, if you track any of the Kubernetes stuff online, you realize that it has a tremendous number of developers not at Google contributing to it, and that's a wonderful thing to see. So the on-prem and hybrid things are actually evolving quite quickly. And finally, I just want to point out that, again, the reason this leads to a Wave 3 cloud is because we know more about what the app is trying to do. We can see how the pieces fit together. We can load balance different parts of the application independently. We can see how the data is replicated and help you down the road with disaster tolerance and things like that. So it's really, it gives us more leverage too, which means more automation. And now it's your turn. Right? The point here really is not so much that containers are great, it's that they let you focus on what you need to do, right? So we want you to focus just on your application and get everything else you need, whether that's distribution, revenue, and scale from us. Thank you so much.